All right, onward. So today it is my pleasure to introduce Sarah Rosenthal from Columbia University. She is working on her PhD. She's in her final year at the university. Her thesis is on detecting influencers in social media discussions, and that will be the subject of her talk today. She has been looking at problems all the way from predicting age to opinion, agreement, persuasions, claims, influencers. She's looking at web blogs, microblogs, discussion fora, and she also previously interned at IBM and Google, where she also was looking at sentiment analysis and discussion analytics. She's an organizer of the popular SEM-Eval task, which is sentiment analysis in Twitter. So with that, I'll let you take it away.
Thank you, Bonnie. So Bonnie's basically touched over everything I'm going to talk about. So we've already seen the title. There we go. So the motivation for why you would want to detect influencers. It is in dialogue. It is useful for product advertisement, politics, and defense. And this comical picture kind of shows an example of somebody who's influential and convinces other people to vote for somebody. And as I was giving this practice talk at Columbia, my advisor, Kathy, actually told me of a story like this that had actually happened to her that day, where she went into the elevator and two of the other senior faculty members were talking about voting for somebody for the Democratic primary elections, and they were talking about someone who's very good for science. Kathy hadn't even realized there was an election, and when she heard that, she was like, "Oh, I think I'm going to go vote for him too." So it was a real world example. So this is just an outline of what I'm going to talk about. I'll introduce more about the topic. I'll talk about the data that I'm using, the components of influence detection, and then conclude. So to first continue with the introduction, I'm going to just talk about some of the background. Of course, the question is, what is influence? We define influence by using Robert Cialdini's book called Influence, the Psychology of Persuasion, where he defines influence using several weapons, what he calls weapons of influence, which is what people use when they want to be influential. The first one is reciprocation, that people tend to return favors. The next one is commitment and consistency, that if somebody says or writes down that they're going to do something, they are more likely to honor what they said. The next is social proof, that people tend to follow what others do, especially if the person is similar to them. Liking, people are more likely to be persuaded by somebody that they like. Authority, that people who are an authority tend to be obeyed. And lastly, scarcity, that if something is perceived to be rare, then it generates demand. Like if you go to, you're going to buy a car and the salesman says, "Oh, this is the last one left," and you get all nervous and that you have to buy it right away. So these weapons of influence inspire our system components, which I will be talking about throughout the talk. And as I go through each one, I will say how they relate to the weapons of influence. And just briefly, the contributions that you can keep in mind throughout the talk. The system is used for predicting who is an influencer in online discussion forums. We provide an evaluation of a rich set of features that are inspired by social science. Each feature set is complex and computed by a system component. And we also do a comparison of differences in several online discussion data sets. And now I'm just going to briefly discuss some related work in influence detection. So the first area where influence detection has been studied is in social science, and this goes back to around 50 years ago, and obviously a little bit more recently as well. I don't have any references here, but if anybody is interested in any of them, I can provide them at a later time. So, of course, first, influence has been defined, as we already discussed the weapons of influence, and then there's also work by Katz and Lazarsfeld, which discuss personal influence in this two-step flow of conversation, which looks at how influence propagates through people, from mass media to opinion leaders to the general public. And lastly, there's also been work looking at how influence flows in conversations and what kind of things you can get out of it. Like there's a correlation between conversational behavior and how influential a person is perceived. And then also there's been work looking at that looks at the contribution proportion of turns and number of successful interruptions are indicators of influence. It's pouring really hard. And the next area that looks at social influences in social networks, which this work investigates how influence is diffused in a network. And they have found things like influence is driven by a mass of individuals as opposed to the influencers. Influencers tend to be people who have been influential in the past and who have a large number of followers. That's, of course, happens in Twitter. And there's also been work that looks at how demographics affect how influence spreads. And lastly, just related work in the natural language processing area in detecting influencers in a conversation, as I do. There's been work that has shown that interruptions, topic initiations and shifts, and dialogue behavior are all indicators of influence. This work is done by more than one person. There's also been work on looking at power, which includes influence amongst other kinds of power. And in that work, there's been research in the role of gender on power and the effect of accommodation on power. How our research differs from all of this is that we employ a richer set of features building off of several system components. So this, of course, lets us get improved accuracy. And it also, the main difference is that it allowed us to provide a detailed analysis as to why the person was chosen an influencer. As I'm going to show the components that we used, those components help you get a more stronger insight as into why that person actually was influential. And again, we also compare influence and its components in multiple online genres. Now I'm going to talk about the data that I use for detecting influence. And there are 5 sources of data. The first one is LiveJournal. That's the one on the right there. And this one is weblogs. So there's the first user is the owner of the blog, and then people reply to them. The next one I'm going to talk about now is Wikipedia talk pages, where people discuss edits for a Wikipedia page. And those two are what I've used for training on influence. Also, from all of these data sets, they're also used in the components of influence. And these last 3 are used, I have data related to influence for the 2012 political elections in the primary. And the first one is Political Forum, which is a discussion forum all related around politics. The next one is Twitter, which is microblogs, and this also, though, we have data related to politics. And the last one is Create Debate. And Create Debate is, it's like a discussion forum, but it's a debate where can be 2 sides or even more than 2 sides. So you kind of get, like, as you see in the screenshot, kind of 2 sides, the yes side and the no side. So it's like kind of 2 discussions going on at once, but, you know, there could be overlap. So this is an example of an influence in a discussion. Just before I go into a little bit more of detail, I know this is a really pretty picture. So this was actually, we had a year or 2 ago, there was an initiative to put some artwork in the floor of our lab. And so someone suggested creating a discussion, influence discussion. So this is the one that is there. And on the bottom it says, there's like a blurb that says, there are several different components that make up influence. Can you tell who the influencer is? Kind of like an open-ended question, so people could read through the discussion and determine it for themselves. I know you probably can read it very well, but that's not so important right now. But I'm just going to mention what conversation it's talking about. It's a discussion about investigating torture claims against President Bush. And in this conversation, Cupio Minimus is the influencer. That's the one highlighted under right here. And the reason that Cupio Minimus was determined to be the influencer is because he provides supporting evidence. People agree with him, and he agrees with people, and he attempts to persuade. This is only a portion of this thread, actually. Not all of it would fit on the page. So as I go through the different components, I'm going to highlight where the components fall under the discussion. So now we can move on to the influence components, and there are several. This is a pipeline. Everything feeds into influencer. The opinion detection system is a subsystem which is used in agreement and claim detection. And then there are dialogue patterns, which are based on the structure of the thread, such as who had the initiative of the conversation, who started it, if someone was ignored, things like that. And then there's agreement, claim detection, argumentation, and attempt to persuade. Now, claims and argumentation feed directly into influencer, but they also make up persuasion. Then there are demographics like gender and age, and lastly, credibility. So I've highlighted now the components that I'm going to focus on, as these are the ones that are the main contributions of my work. But if anyone has questions about the other ones, I'm happy to answer them. So the first one that I'm going to talk about is opinion detection, which again goes into the agreement and claim systems. Now I'm going to motivate it with the weapons of influence. The first weapon that motivates opinion detection is reciprocation. Speaking positive compliments and praise about someone are likely to cause reciprocation. So this is also motivation for using opinion detection in agreement. And the next one, of course, liking. If someone is more likely to be influenced by someone that they like, even if the compliments are false. So if you're saying positive things, then detecting that will be useful for detecting if somebody is influential. And this is the opinion detection data. We have 4 different data sources: LiveJournal, the MPQA, which is by Wiebe et al. That is mostly Newswire. Twitter and Wikipedia, and these annotations were done on the phrase level. As Bonnie mentioned, I am one of the co-organizers for the SEMeval evaluation on sentiment analysis in Twitter, and so that is why we have a lot of Twitter data. As you see, those numbers are a lot larger. But all the data other than the MPQA was annotated using my annotation style. On Mechanical Turk for subjectivity and polarity on the phrase level by 3 to 5 annotators, and then those annotations were combined using intersection. So for example, in the LiveJournal sentence, at least 3 people said that cool was positive and colorful and artsy, so those were all labeled as positive. So this just talks about the method for detecting opinion. So the first thing that we do is we have several dictionaries that we use. And the method that I use is based off of prior work by Agarwal et al., which does phrase level polarity using the MPQA, and then I've geared it towards social media. And the main dictionary that's used in this work is the Dictionary of Affect and Language, which has 3 scores. The first one is evaluation, which is the pleasantness. The next one is activeness, which says how active the word is, like run is an active word. And the last one is imagery, which is how well you can imagine it, like a table is something that you can imagine. And these scores are on the scale from 1 to 3, and there's 2 examples here of happy and sad. So you can see happy has a high evaluation and sad has a lower evaluation. The Dictionary of Affect and Language has around 8,500 words in it, so we want to augment that with other dictionaries to get to get more coverage. So the first thing we do is we look at if something is a proper noun, in which case it is usually not subjective, and we just automatically designate it as objective. Then we also use WordNet, and then use the synonyms to find it in the Dictionary of Affect and Language, and then use those scores. We also use Wiktionary, an emoticon dictionary, which is mapped directly to the Dictionary of Affect and Language. And then we also look at word lengthening, such as sweet, and then we try to map that to sweet and take that. So then those dictionaries are used to create other features, which are then used to detect opinion. The first group of features is lexical features, such as n-grams. There are syntactic features such as the position of the phrase and the subjectivity of the phrase. We also have a feature for using Cent-to-WordNet, which is an opinion score dictionary on top of WordNet, and we just take the average score for each phrase as a feature. And then there are also lexical stylistic features to make it geared more towards social media. And this is a list of the lexical stylistic features. For example, like how many emoticons were in the phrase, if there was repeated punctuation, question marks, word lengthening, and so on. If you just take one more look at this, just pointing out that I am going to refer back to this throughout the talk as I use these features in several components. So these are the results for opinion detection. This is for subjectivity and accuracy. The accuracy is classified using logistic regression. Objective is always the most common, is majority, and that's what the baselines show. And then I ran results using balanced and unbalanced data, training and testing on in each domain, and then also combining them all together. That's what the last column is. And I've highlighted here the system that we used for detecting influence, for opinion in the detecting influence system. And this, we use the balanced one because we're interested in finding subjective phrases. So we want to kind of, if we use something unbalanced, then it would lead more towards having objective. And this is the polarity results. Here you could see that in some domains it's much easier to detect influence in Twitter and LiveJournal. To detect polarity. And this, again, is the system that we use in detecting influence, all of the data, because our data in influence is also widespread. And just interestingly pointing out that it's the data actually, if you take all the data together, then it ends up being balanced because two of the domains are mostly positive and two of them are more negative. We also do perform three-way classification on polarity using neutral, but as you could see, it does worse, and we don't really need the neutral category for opinion detection in claims and agreements, so we just use positive-negative detection. We also ran some experiments across genre to see how the training and testing on the different data sets performs. And so this shows using the system that I described as the one that we use for influence detection. This shows the results for that. And you see some interesting things that when you're training on the data sets and testing on MPQA, that's the hardest one to predict. And LiveJournal is the easiest to predict, and it actually does as well and sometimes better with training data other than LiveJournal. And in terms of training, using the MPQA to train does the best on testing the other data sets. And all these results are encouraging for applying domain adaptation to opinion detection. The next component that I'm going to discuss is claim detection, and this again feeds into detecting if someone is an influencer, and is joined with argumentation for attempts to persuade. So the definition for claim detection is that an opinionated claim expresses an assertion that is an opinionated belief. And these are just some examples from the two corpora that we use in this detection, LiveJournal and Wikipedia. A good photographer can do awesome work with a Polaroid or phone cam. And the goal is to make Wikipedia as good as possible and this article as good as possible. So these are assertions and they're opinionated and the people believe what they're saying. Now, to motivate claim detection by the weapons of influence, it is motivated by these three weapons. The first two, reciprocation and liking, which I just motivated before with opinion detection, which is part of claim detection. And the last one is commitment and consistency, and this is motivation for using committed belief in opinion detection, because you have to believe what you're saying when if you're claiming it. And this is some examples of claims in the influencer discussion. And I'm just going to highlight two. And we all know the government doesn't rat itself out. That misspelling is there on purpose. That's what the person wrote. And honestly, I believe in torture, but only in torture of the deserving. This is the method that we use to detect claims. We use the opinion detection system. We run an opinion on the sentences and then take that output as features. We also use a committed belief. This is a system by Prabhakaran et al. At Columbia, where the sentence is tagged for belief. Any of the verbs are tagged for what kind of belief they are, and we use that as features as well. We also have a question feature, because if someone is asking a question, then usually it's not a claim. There are also lexical features like n-grams, and the lexical stylistic features, which I mentioned in opinion detection, are used as well. So this is just talking about the data and experiments for claim detection. We had 2,000 training and 200 testing sentences in each of the genres, LiveJournal and Wikipedia. And each sentence was annotated by 2 people, and all disagreements were resolved. So the top experiments show running on balancing a training data and running on a test set. The test set was not balanced. And the baseline that we use is the question feature. And you can see that we beat the baseline. So the best features differ for each corpora. For LiveJournal, it's belief and the belief features and part of speech features. And interestingly, when you look at the cross-genre experiments, training on even though we were training on Wikipedia, the best features for LiveJournal again were still the belief and part of speech. And with Wikipedia, we found that as well, that the best features, whether you were training on Wikipedia or LiveJournal, but if you were testing on Wikipedia, were the question, n-gram, and part of speech features. And those results are encouraging for domain adaptation. And lastly, the last column shows training and testing on the LiveJournal Wikipedia combined, and in that case, the belief, n-gram, and part of speech features were the best. The next component that I'm going to discuss is agreement detection, which is fed directly into Influencer. And agreement is defined as between a quote and response pair. It occurs between 2 posts where one is an immediate response to the other. The first one is called the quote, and the second one is called a response. For example, this small little example where the first person says, "Any objections?" and the second one responds, "Not a problem." And that's a simple example of agreement. Now, I'm just going to motivate agreement again by the weapons of influence, and it's motivated by several. The first 2 are reciprocation and liking. This I also mentioned earlier, but if someone says something nice to a person, then they're more likely to agree with them, to reciprocate in that, and also that means that they like them. And if someone says something rude to a person, then they'll be more likely to disagree with them. And this is also motivation for using polarity in agreement detection. The next one is commitment and consistency, that if someone agrees with somebody else, they are more likely to continue to agree with them. And this is just a cute little example of this, that people were gone knocking door to door and asked to sign a petition to keep California beautiful, and this is no big deal, so most people signed it. And then those same people were, a few weeks later, the person knocked on the door and asked them to put a "Drive carefully" sign on their lawn. Now that's something that most people may not like to do, but the people felt they had to be consistent with what they had said earlier, and they felt that they had to put the sign on their lawn. And this was actually 76% more likely, the people who had initially signed that petition versus people who had never been gone to were more likely to put it on their lawn. And lastly, scarcity, which is again that people are influenced more if something seems to be restricted. So restrictions are likely to cause people to have a negative reaction by defying and disagreeing with the restriction and the person who placed it. And back to the influence thread, these are the examples of agreement and disagreement. For example, "I must disagree with your numbers, as most Americans are unaware that best estimates put the actual number of dead in Iraq since the start of the invasion in 2003 at 1.2 million people." So that's an example of disagreeing. And the next one, of course he should, yes, that's an example of agreeing. So the data that we use here, we have several data sets. The first one is the Create Debate, which is a website where people can start debates, and there's 3 kinds of debates on it. There's open-ended ones where there's no side. There's a for or against 2 sides, and then there could also be multiple sides, 3 or more. We focus on the debates where there are two sides. So each post is labeled with the for or against side, and these are in quotes because they don't actually have to be called for or against, but one side indicates for and one side indicates against. And we use these labels that the people put on their post to convert them to whether they agree or disagree with the person that they're responding to. If the quote and the response have the same side, then they agree, if they're both for. If the quote and response have a different side, one is for and one is against, then they disagree. We also have some cases where there is no agreement, and that is if the quote is the root, because the root is the person like asking a question, so you can't agree or disagree with them. And also if the quote and response have the same author, then we consider it to be like an extension of the original post, so there's no agreement or disagreement. And we call this data set Agreement by Create Debaters, or ABCD. And this is an example. So as I said, so here the 2 sides, this is about Diet Coke, regular versus Diet Coke. The 2 sides are regular and Diet Coke. This is an example of disagreement. Diets are nasty. Coke is the only soda in the world I'll pretty much tolerate. So they are for the side of regular. And then the person responds, why are diet sodas nasty? They contain artificial sweeteners which actually start tasting good after you drink them for a couple of weeks. The upside is that you aren't consuming a can full of sugar, i.e. empty calories. So they're for the side of Diet Coke. And this is an example of agreement. They both are on the side of Diet Coke. While Diet Coke is more likely to kill you and cause cancer and stuff, but it does taste better. Death tastes yummy. And then the person responds, death does taste yummy. So the next data set that we use is the Internet Argument Corpus, which it was created by Walker et al. And that was annotated on Mechanical Turk using a scale between -5 to 5, where -5 to -1 indicates disagreement, -1 to 1 it indicates lack of agreement, and 1 to 5 indicates agreement. The important thing to note about this data set is that not all the QR pairs in a thread were annotated, just some of them. And the difference in this data set, which we created, called Agreement in Wikipedia Talk Pages, is that each thread was annotated in its entirety, and they were annotated using this annotation tool, an annotation tool, which is a web tool, and the format is shown over here. This is the discussion in its threaded format. And then there are controls on the side for saving the data, controls to label whether the sentence is agreement or disagreement, and then you can also see all the posts that you've already marked. These annotations were performed on the sentence level by 3 annotators, and the inter-annotator agreement was computed on 30 sentence pairs, and the Cohen's kappa was 90% between 2 of the annotators and 70% between the other 2. We did basically the 3rd annotator compared against the first 2. And we converted these sentence-level annotations to post-level annotations using the majority sentence-level annotation. In most cases, there was just 1 sentence that was annotated, so it was pretty simple. There were maybe like 3 cases where there was a tie, and in those cases, we took the longer sentence. This is some just statistics about the data. As you can see, the ABCD is significantly larger, and that is because we use naturally occurring labels for the side information. Something else that's interesting to point out is that all of these data sets are more argumentative. You may not find this in all discussions, but in these ones, disagreement is far more common than agreement. So we divide this into training set to be 80% of the discussions, and the test and development sets are 20% of the discussions. For Wikipedia, we did not use a training or test setting or a dev set because it was small, so we just used that as a test set. The method for detecting agreement uses several features. The first one is features related to the thread structure. For example, if the person was the root of the discussion. The next one is a question feature. If they were asking questions, means that they're more likely that they were not agreeing. There's also lexical features such as n-grams. And we also use the linguistic inquiry word count by Pennebaker, which has words and what categories they belong to. And we use each category of the words in the post as features. We also use, again, the lexical stylistic features that I mentioned in the opinion section. We use opinion detection, polarity, and then we also use sentence similarity by Wei Gao and Monadia. And this looks at how similar the sentences are, and we look at whether there's a very similar sentence in between the quote and a response. And we also look at phrases on the phrase level, whether there's similar phrases and if their polarities match or are different. If they have similar phrases that have the same polarity, then that would indicate agreement. And if they have different polarities, it would indicate disagreement. We also lastly use accommodation to see whether the response person is trying to accommodate to the style of the quote. And we do this, of course, by sentence similarity, but also whether they share part of speech, lexical style, and the LIWC categories. We ran our experiments using logistic regression. We did our detection three-way between agreement, disagreement, and none. We use a balanced training set, and the results are shown in the average F-score over the three classes because disagreement tends to be rare. And this is especially the case in the IAC and AWTB corpora. Just a quick reminder of what the F-score is. It's computed using precision and recall, where precision indicates of the data predicted to be true, how many are correct, and recall says how many true cases are found, and the F-score is the harmonic mean of precision and recall, as shown below. So this first experiment shows what we tried to do was to see as the size of the create debate corpora in training set increased, how does that improve the overall F-score? And as you can see, which is good, it does improve as the size improves. The bottom shows the number of posts, and this shows the F-score, and at best we get 77.6% at average F-score when using the full corpora. So now the big question is, can the ABCD corpus be used to predict disagreement in other corpora where we do not have a lot of labeled data? So the first experiment looks at the internet argument corpus, and the purple line shows training on the ABCD and testing on the IAC, and the green one shows training on the IAC and testing on the IAC. This line, I think I have it on this one, indicates the size of the IAC. So this is where you can't do any better on the IAC. That's why it's straight over here. And as you can see, of course, as when the ABCD is the same size as the IAC, it's when the IAC does better, which is what you would expect. But as we get past this line, and we have a lot more ABCD data, we actually can do as well, even slightly better than using the IAC. The next experiments show using the Wikipedia talk pages, and as I mentioned, we don't have a training set because of the small size, so we compared using training on the IAC, which are gold labels, and testing on the ABC and training on the ABCD, which are naturally occurring labels. And when they're smaller, this again is the size of the IAC. The IAC does do better, but as you include more and more of the ABCD corpora, you actually can do much better with the ABCD. These are just some individual results using the different kinds of features. The top row, the top one, this one shows the training, and this one shows the test. So the first thing I'll point out is that using thread structure and accommodation outperforms using just thread structure or just response features without basically ignoring the quote. And this just shows what the best results are. And this is again showing the best numbers from the graphs. And as you can see, using naturally occurring ABCD labels does as good or better than smaller manually annotated data sets. And the best features obviously differs for each training corpus. The next component that I'm going to talk about is demographics. And this is motivated by 3 weapons of influence. The first one is social proof, that people are more likely to be influenced by someone who is similar to them. And there was an interesting findings that it's called the Werther effect, that if there was a suicide reported in a newspaper, it caused similar people to commit suicides. For example, if it said that a lawyer had committed suicide, then they found that in the following weeks there were several other lawyers that committed suicide. So you could come up with many reasons why this may happen. Maybe those people were depressed as well, and this gave them motivation to follow through with it. The next one is liking, that association to a person through age, location, or gender will cause liking. And the last one is scarcity. This is a very specific demographic, but teenagers have been found to be most affected by restrictions. The data that we use here is from LiveJournal, 24,500 LiveJournal blogs, which were gathered by the year that the person put down as their birthday. This kind of shows from older to younger, and you can see that most of the people are born around the 80s. And
just to understand that better, those are the people who've initiated blogs?
Yeah, these are bloggers.
But not that
This for here we didn't use the comments.
They're not the commentators.
Yeah, in this data, the training for this data set, we didn't use the comments. We just used the blog posts.
Okay.
And so this shows the demographics for gender. This is a subset of the age data set. What we did here is for the people that reported their name, we looked up that name in the U.S. Social Security database and checked whether it was more associated with a male or female gender, and we came up with 6,091 males and 7,412 females.
Do you have any objective way of knowing that the poster, that name the person actually was male or female?
No, it's totally based on their name, but I did a 2-to-1 ratio, so it has to be a 2 times more likely name to be male versus female. And the method used here, the first one is online behavior kind of features, like the number of posts, the number of comments, the time that they posted. The next one is the lexical stylistic features. Again, these are the ones that I introduced by the opinion detection. And the last one is lexical content features such as engrams, collocations, and part of speech. And these experiments, for age, we use linear regression to get kind of an exact year, and we found that it was within 7.1 years above or below the actual year. And for gender, we got it using logistic regression at 76.5% accuracy. The majority baseline of female is 54.9%. The more useful features were engrams, online behavior, and lexical stylistic content. In the future, this is actually something that I'm hoping to do. Now I have a student working on it, who's going to start working on it, is to explore other demographics, namely politics and religion. And I'll just briefly say what we want to do is there are some websites where you can kind of categorize yourself for Twitter. As what political party you're in or religion. So we want to gather that data and use that to get popular words associated with different political parties and religions, and then use that to detect these demographics and influence. Oh, I'm missing the outline here. Okay, so the last component that we use is credibility, and this is motivated by two weapons of influence. The first one is commitment and consistency, that people who are consistent with what they say are more likely to have credibility amongst others. And the last one is authority, that an item becomes more desirable if it is associated with a person that one can relate to or trust. And people tend to be influenced by those of higher authority. Again, going back to the discussion thread, there's several mentions of credibility here. For example, the first one is that the person misspelled government, and that would be an example of perhaps a lack of credibility. And the next one, the person reported numbers, which makes it sound like they know what they're talking about. And these are the features that we use for credibility. The first one is links, which is if they reference a URL to something, if they quote things, if they mention honorifics, such as a president or a judge. Name mentions, this is if somebody is, both if someone is referred to by other people, so this is authors in the same discussion, or if they refer someone else, this could indicate how credible somebody is. Misspelling is a lack of credibility. Numbers can indicate credibility, and asking questions could indicate a lack of credibility. And all of these features are included directly into the influencer system. So now I am ready to discuss influence detection as a whole. So first I'm just going to come back to the pipeline, which I discussed before. So opinion leads into agreement and claims. Dialogue, agreement, claims, and argumentation attempts to persuade, demographics, and credibility all feed right into influencer. Claims and argumentation make up an attempt to persuade. Now, I'm not going to go into all of the features, but I just want to point out that each component consists of many features. There are several dialogue features, several agreement features, and so on. For example, we have, for claim, the number of claims in the post. We also have, is the first post a claim, because maybe that indicates that it's more strong. Now I'm just going to talk about the data for influence detection in a little more detail. So the number of files for Wikipedia and LiveJournal, this is what we use for training, and we also run test experiments on it. So there's 509 Wikipedia files and 221 LiveJournal files, and there's 464 influencers in Wikipedia and 224 influencers in LiveJournal. So you can see there's around one influencer per thread. And you can see that there's a lot more authors than, obviously, the number of influencers. For our experiments, we exclude threads where there were no influencers. And we have held out test sets that's 10% of the data. And for Wikipedia, we also have a dev set that's 10% of the data, which is what I've mostly been using for tuning. There are 5 annotators, and I computed inter-annotator agreement using Cohen's kappa between each two pairs of annotators, and on average, it's 52.9%. The last group of data sets we only use for testing, and all this data is related to the Republican primary in 2012. These data sets were collected using keywords such as Mitt Romney, Occupy Wall Street, and so on. And we again exclude threads where no influencer exists. As you can see, these ones are much smaller. Again, influencers are rare. This is important because it shows that it's a really hard problem. The number of influencers per thread is 0 to 2, with 1 being the most common and 2 being rather rare. You could have more, but I have yet to see it. And I just put down the influencer to author ratios. You can see where in some discussions it will be harder to find influencers, namely Create Debate would obviously be the hardest because there's still just 1 influencer, but there's 20 authors. So now I'm going to talk about the experiments and the different training and test sets. And these experiments were run using logistic regression. We compute using F-score of the influencer class because, again, they are rare, so the accuracy would obviously be high because most people are not influencers. And we also use ranking to help us improve our scores. We tried with and without. And for ranking, what we do right now is using the system confidence from logistic regression. Even if the person who had the most confidence, even if they were not picked to be an influencer, we will pick them to be the influencer because we know in our model that we excluded the threads where no influencer exists. So every document must have an influencer. In the future, we want to look into trying different ranking evaluation metrics to rank all the people in the discussion by how much influence they have. So the first results are using LiveJournal as training and testing. The baseline in this data set is 29.1% F measure, and the best system gets an 80% F measure using only the dialogue features. And the reason that we think this happens is because usually the blogger is the influencer. This makes sense because it's their page, and most people aren't going to argue with the blogger if it's their area. The next experiments were on training and testing with Wikipedia, and here the baseline is 28.9%, and the best system gets an F score of 52.7%. Using dialogue features, agreement, attempts to persuade, and demographics. I have to do more research into exactly why these features have been the most useful. Though Wikipedia is very argumentative, so it does make sense that persuasion and agreement/disagreement would help there. The next one is Create Debate. So this is training on Wikipedia and testing on Create Debate. And in this case, the baseline here is 9.5. So this is what I was saying. Again, there are so many people in each discussion, so it's much harder here. And that definitely shows in the best system with a 24.6 F score. And in this case, the dialogue and claims features were the best. I have to do more of analysis here. As I mentioned, there's a lot of people in each conversation. And then the next one is the political forum, where in this case, the baseline is 15.4%, also pretty low, but the best system does do better with a 52.9% F score, using claims, attempt to persuade, demographics, and credibility. And in this case, actually using the ranking helped do better. And the last one is the Twitter results. I saved the best for last. Detecting influence in Twitter is actually, I think, rather easy. So the baseline, again, is low with 12% F score because there were, I think it was around 15 people in each discussion. But we get an 86.6% F score using the best system, which also uses ranking, using dialogue and agreement and disagreement. So I do think I know why this is the case here. It seems to be a little more obvious. Usually the author of the first tweet is usually the influencer, which is a dialogue feature. And also the influencer is usually retweeted often, that would come out in agreement and disagreement detection, and that's why you see that being useful. Something that I might try in the future, we also have labeled whether the influence in the Twitter discussions is more of a retweeting kind of influence, where just popularity, or if there's a real conversation going on. So I may look at the conversation one separately and see what we'll probably get a worse F score there. So now I'm going to conclude with summarizing everything and also talk about some future work. So the first thing that we want to look at is cross-genre and domain adaptation. So as I've shown over the past few slides, the weapons of influence that work best differ depending on the situation. In fact, over all of those different data sets, we've covered every single one of the components as being part of the best system, but this differs for each one. So I want to continue to perform extensive analysis to answer why each component works in each genre. I've shown a little bit of why that happens, but I want to look into that in more detail. and to analyze how components interact with each other. There is also a lack of annotated data, especially in the political domain, and I probably won't be able to get enough training data there. So what I'd like to do is look at if the similarities between corpora can be exploited to perform domain adaptation to get better results. The next thing that I like to do is also look at influence trends to track trends in topics and entities over time. So to be able to answer questions such as who are the influential people on the topic per day, which days were the most influential. An example of a topic would be things in the political domain like Mitt Romney or the Occupy Wall Street. Which online genre had the most influencers on the topic? How did the influence of the topic spread across a genre? Can the trend be related to a major news event? And with that last bullet point in mind, we'd like to try to link news summaries and URL links to the influence in the online discussions. And this is just a mock-up of what I would like to have something like this ultimately for analyzing the trends, where you can kind of search any topic, which would be some keywords, for some time period, and then you would get back a graph of the influence in the different domains, where here each one indicates the number of influencers on that date in all the discussions related to this person. And you would also get on the right-hand side some information like who were the top influencers, supposing that there were repeating influencers across different discussions, what are the popular words related to in these discussions, and then news articles related. So to conclude, we have a working system that detects influencers in a thread. This system is motivated by social science. We are going to continue to explore political threads across multiple genres and apply domain adaptation, and we will explore trends over time on the political threads using topics and entities. I would just like to thank all the people that have worked with me on this in the past, obviously my advisor, Kathy McEwen, and Owen Rambo, who's been like a second advisor. Orby Ron did a lot of some of the earlier work with influence. He's is the one who implemented the persuasion system and came up with a lot of the dialogue features. The rest of the people are students that have worked with me on different aspects of the project across my PhD. These are a list of references related to the work, which you could find on my webpage. That's it.
So, two things. One, I want to take issue with one assertion you made, which was that a question is not a claim. There's certainly, when did you stop beating your wife? Is a claim.
In general, it's not going to be.
So we can, in any domain, you can make these questions up, and you often see questions that are designed to be provocative in these kind of debates. And I mean, how do you respond to a question like that? Somebody might say the question is illegitimate, but it's very difficult. So that's one point. The other point is there's no way to tell in the approach, and maybe it's just something to think about for the future, about the number of lurkers, people who actually view the debates and may or may not respond. And you don't know sort of when they started looking at it and how long it took them to jump in, if they ever jumped in, or whether they spoke about it, viewed it on one site and then tweeted about it on another. So there's a large population. It's really only the people who are going to be the most opinionated, right, who actually participate.
I mean, there are some things that we do to address things like that. We do have time features, how long it takes someone to respond to something. But there also are things that we don't use on several of these data sets, which we could ultimately use, except, of course, they're not available across all of the domains, there are things like likes. Create Debate has that you can upvote a post that somebody does. So that would kind of get, those people might not actually respond.
Likes and favorites and
Yeah,
things like that.
and obviously Twitter has that, I think, as well. But yeah, I mean, you only can do with what you have, you know. I think that also touches on like the network, social network aspect, which is like the other side of influence.
Did you do anything as far as trying to detect native speakers versus non-native?
No, we try to focus only on English. For some of the data we were able to, like with LiveJournal, we tried to do just people who are in the U.S. Obviously not perfect, but they put their geographic location. Mm-hmm. There has been a little bit of work in other languages under the skill project in Arabic, but that hasn't been a focus yet.
Okay, take Adam, and I bet Micah has a question.
Yeah.
Go with Adam first.
One of the weapons of influence you said was that people are more likely to be influenced by people who are more similar to them. Mm-hmm. And that made me think, have you looked at all to the relationship between influence and deception? Because that seems to be a technique applied by, especially in the cyber domain, people phishing. Cyber phishing. When people send you an email to try to get you to do something bad, they'll oftentimes try to look like somebody who is in a position of authority or somebody that you know. So I guess that's another one of the weapons of influence. It seems like people who are trying to deceive use these same weapons.
Yeah, so one of those points actually, I don't remember which one, but one of them said that, I think it was with liking, that people are more likely to like someone who says things nice to them, even if they're lies. I mean, detecting deception is a whole other area, but it is it's like cracking the code, and now that you know what the weapons of influence are, you can use them to your advantage.
Any other questions? Micah.
First, this is really nice work, and you should be commended for it. I have to say that I'm incredibly pessimistic about the whole approach, and that's not directed at you. That's really just directed at sort of the machine learning approach to the social linguistics. I think that using machine learning techniques on a whole class of different features at varying levels, and then seeing how well those, which subsets of those best correlate with a human annotation, which again we have no baseline or theory for why or how the humans are doing it, and simply seeing what collection of features best correlates. It doesn't tell you anything about the nature of influence. It doesn't tell you anything about how people really use language in different settings. For example, the fact that different feature sets work best in different language usage contexts that are superficially different, but are all language uses, all should be examples of influence. I think is evidence that this is the wrong level of analysis for a social linguistic concept. Certainly when people look at influence, whether it be in a tweet or a dialogue or a real world debate, they don't look at features. They don't do classification. They imagine, what's it like to be that other person? Why are they telling me this? What is their goal? What is their ulterior motive? They use a much richer and much more symbolic set of tools than what the machines are able to do. So I'm just, that's all right. I'm loud and focused.
Yeah, it does the battery when
all right. Well, I just, so I can see applications in specific domains where you can say, these are the appropriate features to use for tweets. But I just don't know what it will give you as far as going cross-domain. I'm not sure what kinds of claims you can make about how language features, how those relate to psychological and cognitive uses of language in people. Well, so I guess I'm asking, what is the point just to be doing to detect influencers in specific domains?
Yeah, I mean, the point is to detect people who are influential or at least seem to be influential. And I think using these complex components actually lets you get at why someone is influential, because you can look on a per discussion basis and say this person was influential because they they had people agree with them, and look, here are specific examples of where people agreed with them.
Well, but again, people agreeing doesn't mean that they've influenced. So
Well,
I might agree with my boss, and everything
they are
he tells
showing
me, I never
character.
agree with him in person.
Well, you have to show enough characteristics to make it seem that it's influential, and hopefully, I was just giving one example. There's usually more. Obviously, it's not perfect.
So is
but
there a crisp definition of influence that would have necessary and sufficient conditions that would be meaningful either as a normative standard or as a true psychological standard that could be validated?
So there is a definition that we have used, like what we give to the annotators, and I think I mentioned this to you when we were discussing it before, that every research area, like political science, social science, everyone has their own definition. So I think actually it's kind of nice to get away from the definition and say, well, what about just looking at what sort of characteristics the person has? And, well, it seems like that is indicative of influence in this case.
Well, but the F scores that you're measuring aren't measuring that. They're measuring how well do the features we're correlating, we've chosen for our classifier, how well they match up with how people have labeled when we gave them this subjective definition of influence and left them to their own devices in annotating a document. I mean, that's really what you're measuring against.
That's what I'm showing. I couldn't show everything, but I think it would be nice to show a more detailed analysis also. And then when you get to the trend level, you don't care as much about the exact accuracy, because it's more of an overall picture of people that seem to show influential properties. And actually, I think something that is important is that we don't know for sure if these people ended up being influential, but they seem to have characteristics that make them look like an influencer.
I see that Dave has a question. I want to ask one quick question, moving us into the application area and just sort of what you see that looking like. How would I, the work that you've done here and the results of your analysis, how would that be realized and either displayed, what would your input-output be, and how would we present that to a user, or alternatively, how would you realize it inside of a larger application such as multi-party dialogue? How do you envision this in the application world?
Well, I'll go back to what we've been using, the political domain, that I think would be something that would be nice, that maybe if you would look at the trends over time and topics and what was influential, maybe you could see why the person ended up being, winning the election, things like that. You could, we actually collected the data, the polling data, like that also happens across time, and you could maybe correlate that with news and the influential people.
So, I mean, as an end application, how presentationally would that look to me if I were going to do that sort of thing? What would I be seeing?
Well, that was like what the mock-up would be. Something like
Okay.
You could use that and kind of gather your own insights.
Mm-hmm.
And then you could use it for things other than politics as well.
All right. I think one more question, and then we'll give you a break.
It's actually more of a compliment. So I really like that phrase, weapons of influence. Maybe you didn't invent that, but...
Robert Cialdini?
Yeah. I don't like using the word weapon too often, but I think that's a good one because there are a lot of those tools. I've spent the last 2 years on my project going through social science, social psychology literature, looking at trust and the elements of persuasion. And you mentioned some of them, but I think there are a whole bunch that might also fit into that domain. You mentioned word usage. So just in this general category of mimicry, right? Lexical entrainment. You use a word, I use the word, I use it sort of the same way. I start matching my phrase structure to yours.
That's accommodation.
Yeah, and so, yeah. So these are really good examples of features. But I think there are a whole bunch of them that have good psychological justification, specifically in terms of their use in persuasion that you can draw on. I know you're not making those up.
Yeah.
Anyway, that was my
I think
comment.
that's what's kind of nice. Adam was saying, you can kind of be deceptive. Like if you want to learn how to be influential, maybe you could also use this to figure out what the people are doing that are getting the most attention.
It says nothing about whether or not what you're being persuasive about is true or false.
Right.
If you want to be a used car salesman, this is exactly how you do it.
Okay, so with the used car salesman comment, we will now, I don't think we think you are that, so that's good. That's awesome. Really nice talk. I want to thank our speaker.
Thank you.